Hi, my name is Kuchta. I worked with Pham on the Smoky Mountain Data Challenge #1. So our task was to find broad features and peaks in single crystal neutron diffraction data. So to do this, we did an algorithm similar to DBSCAN. DBSCAN works on data that has some position according to it. So if some point has some number of neighbors and some radius, is classified as a core point. And if it's a core point, it'll make up a cluster. And these clusters can be any shape, any size, and also there can be any number of them in the data. The problem with our data is we have a grid. Since we have a grid, we'll either have all clusters or no clusters at all, depending on these two parameters. Instead, we made up an algorithm called structured DBSCAN. And how this works is we take our data, which is a grid, and each point is its intensity, and we ask our 2 points neighbors. If they are neighbors, then perfect, and we're looking for some number of neighbors with a core point, mid-neighbors, and radius. But we decide if they're neighbors depending on this minimum value. So we look at the value of our 2 points divided by the distance between them, and if that is greater than the minimum value, then they are neighbors. So as an example on a curve, we can classify some broad feature or some higher intensity feature, just depending on these parameters that we choose. So in order to find the Bragg peaks, instead of the noise, we first get the local maximums. So we get these local maximums from the pooled image to reduce the noise slightly, and we get some histogram of these maximum intensities. And some of them are very low, and some of them are very high. There are actually many more low, and these very high ones are the Bragg peaks. So we ask, are they Bragg peaks? We decide that all the very low intensity are not, and all the very high intensity are, and we create a neural network to classify this. We just have a binary classifier at the end to learn. And since we have very few Bragg peaks, we need to actually make more. And to make more, we take this noisy data, add it to the Bragg peak, and put that through as well. And that's a slightly different peak that our network can learn is also a Bragg peak. And then we do some training and validation, back and forth, and then we do some testing. And if our network is good, we can apply it to the question marks to find our Bragg peaks. Then we can use those Bragg peaks that we just found, their positions, and cluster them using DBSCAN that we just used, and find how they are formed in the dataset. We can also look at the translational symmetry of them. We can take any 2 Bragg peaks, create a vector between them, and ask, is there another Bragg peak in that direction or in the opposite? That's it. Thank you very much.